Hello, this is Michael Kraut with ID Dudes. We're going to be talking about understanding IP version 6 addressing. Welcome to the presentation. If you have any questions or comments, you can put them in the GoGo box at the bottom of the video. Let's get started. So we're going to be talking about IP version 6. Identify the network ID and the host IP ID and IP version 6 addressing. Recognize the types of IP version 6 addresses. Global, link local, unique local addresses. Those are going to be the IP addresses that we're going to be looking at within IP version 6. Then we're going to look at the ISATAP router and how it works, how we can use it to tunnel across IP version 4 because IP version 6 routers are not available yet. And 6 to 4, which is another technology we can use for tunneling. And toredo. Well, you have some practices and exercises. Please do the exercises because they're going to increase your knowledge of IP version 6. Also, give you the hands-on experience that you need for IP version 6 on a Windows 2008 server environment. So how do computers receive IP version 6 addresses? Well, they're automatically assigned, so there's really no physical configuration that we really have to do. Now, we can do a manual IP version 6 address, but it's pretty cumbersome to come up with. What it does is it discovers the neighboring routes, so it's all automatically routable. Uses DHCP version 6 servers is the other thing that we can do. So we can go out and we can put a scope of IP version 6 IP addresses on a DHCP server. Computers always assign themselves an address on a local subnet only, and that's the FE80. Remember, we have automatic IP addressings, or what is known as IPIPA, on a IP version 4 network. Well, we have the same thing with IP version 6, and IP version 6 is known as a link local. And so it's going to give it FE80 type of address, which we'll look more into that later on. So let's take a look at the different IP6 addresses that we do have. We have three types of global addresses, which the global addresses are going to be associated to our public IP addresses that we have in IP version 4. Link local, that's going to be the IP addresses. Well, the global addresses actually are the internal addresses that we use. Link local is going to be our IPIPA. And then we're going to have unique local addresses. So the global address is the same as the public IP addresses in IP version 4. 2000::/3. What that's indicating is that we have a bunch of zeros in there. So we're going to have a 120-bit address when we deal with IP version 6. 2000 to -3 FFF is our public address range or global addresses. The structure is the first 48 bits are the global routing prefix, saying, okay, this is where the actual packets need to go. Next 16 are the subnet ID, identifying the network ID, and then the final 64 bits are an interface ID, which uniquely represents the interface, so that it's going to not have the same IP address assigned to this in the same subnet as being on the same street. Remember, being on the same street, we can't have the same house number. Same thing here. That the 64-bit interface ID is going to be our host address. That's really what it is. So link local is the same as similar to IPIPA addresses. They're self-configured, non-routable addresses, and they remain assigned as a secondary address even after routable addresses have been assigned. This way, we'll never lose communications on a local subnet. FE80 is the beginning always when we're dealing with the link local address. So FE80 000000000 is the actual beginning of the IP address, IP version 6 address. Second half is the interface ID, which is going to have our MAC address, which identifies the actual interface itself. Percentage D is the zone ID. Now, when we look at unique local addresses, they're equivalent to the private IP addresses. FD is the beginning of those addresses. FD65:98BF:EF B00001::, that indicates there's a bunch of zeros in there. 0002. 7 bits are always 1111110, which is 8 bits is set to 1 to indicate local. And the next 40 represent the global ID and is random, randomly assigned based on Windows 2008. Now there's different states that we have for IPv6 addresses. We have the tentative state, which the state will address is being assigned and verified as unique. So what it's doing is making sure that we don't have duplicate IP addresses on that local subnet. Preferred, which is the valid address. So after it's being tentative, saying it's unique, then this is going to be the valid address, which is known as our preferred. And deprecated, that means the address expires. So it's no longer a good address. We shouldn't use this. Now, when we look at the different transition technologies, when we're looking at IP version 4 and IP version 6, one of the things, they're not going to communicate. But what we can do is we can go through IP version 4 using IP version 6 through what is known as tunneling. So there's different technology that allow us to traffic to pass through the IP version 4 network with IP version 6. Next generation TCP IP. What that means is we have a dual stack. Remember I showed you before, we had IP version 4 and IP version 6. ISATAP, which ISATAP allows us to be able to tunnel through IP version 4. 6 to 4 is another one in Toredo. So the next generation TCP IP is native to Windows Server 2008, Vista, and Windows 7. So these are the new kids on the block when we're dealing with IP version 6. It's a dual stack. So we're communicating with both IP version 4 and IP version 6. So if it's an IP version 6 address, it's going to use IP version 6. If it's an IP4, it's going to use IP4. That's the easiest way to think about it. Communicate on IP version 6 and IP version 4. Then we have ISATAP, which is Intra-site automatic tunnel addressing protocol. And IP version 4 to IP versions, or IP's version 6 to IP version 4 is through an ISATAP router. And the address translation is between IP version 4 and IP version 6. ISATAP is composed of IP version 4 addresses encapsulated inside an IP version 6. So what happens is that it's going to be tunneling. This is used for private networks. Then we have 6 to 4. This tunnels IP version 6 over IP version 4 through 6 to 4 routers. So the routers must be able to support 6 to 4. Used for the internet. And then toredo is a tunneling protocol. And this is used when no other technology is available. So ISATAP is not there, 6 to 4 is not there. Then we're going to use toredo. Infrastructure relies on toredo clients, toredo servers, and toredo relays. And toredo hosts specific relays. So those are the components that we need for toredo. Now, testing IP version 6 connectivity is your exercise, reading IP config output. Exercise 2 is pinging a link local IP version 6 address, which is your FE80. Exercise 3 is assigning a unique local address, and the time is 30 minutes. If you have any questions or comments, you can always put them in the Gogo box. Thanks for joining us.